So now we're going to learn about parallel lines. Again, with parallel lines, you know that is two lines that never cross. And when we have parallel lines that are cut by a transversal, we have all sorts of angle relationships that are very important that are going to be used whenever it comes to triangle proofs. So let's start with some vocabulary. So in this picture here, notice how we've got a set of parallel lines. So line L, is going to be parallel to line M. And we use side-by-side lines like that to represent parallel. So L is parallel to M. And right here, the definition says lines that are the same distance apart and will never touch. That means parallel. So L is parallel to M. And then this next picture talks about what we know as a transversal. So parallel. And then now we're going to learn about a transversal. So a transversal is a line that comes through and intersects the parallel lines. So line N in this picture is a transversal. So a line that intersects two or more lines at different points is known as a transversal. So whenever this happens, whenever you have parallel lines cut by a transversal, you have a lot of angles that are made. So the next set of angles that I want to focus on is what we call corresponding angles. So corresponding angles are two angles that lie on the same side of the transversal and are in the same position. So same side, same position. So what I'm going to do is I'm going to number my angles here. And I'm going to name the set of corresponding angles. So same side, same position. So imagine taking a pair of scissors and cutting directly in half right here and sliding and moving everything up. What would be lying on top of each other? What would be basically the same? So if you look right here, this angle 1 is corresponding same side, same position as angle 5. So what do you notice about angle 1 and angle 5? They're corresponding and they have the same measure. If you're corresponding with somebody, everything about you is the same. So angle 1 and angle 5 are congruent to each other. So another set of corresponding angles in this picture would be angle 6 and angle 2. Angle 6 is congruent to angle 2. They're corresponding. Okay, so 1, 5, 6, 6 and 2. What about angle 4 and angle 8? Notice how angle 4 is corresponding and congruent to angle 8. And then the last set would be angle 3 and angle 7. So corresponding angles are angles that lie on the same side and are in the same position. Again, like I said, imagine taking a line and cutting right here in half and sliding on top, and all of these angles would fall directly on top of each other. Okay, so now, the next set of angles. So again, I'm going to number my angles, but in this situation, I'm going to focus on a certain set of angles. So angles that are inside the parallel lines and on opposite sides of the transversal. So inside my parallel lines are these angles right here. But when they're on opposite sides of the transversal, they're known as alternate interior angles. So alternate interior angles would be angles like this one, 3, and angle 6. Angle 3 and angle 6 are alternate interior angle. And what's special about them is they're congruent to each other. So angle 3 is congruent to angle 6, and they're alternate interior angles. Okay, so another set of alternate interior angles would be angle 5 and angle 4. Angle 5 is congruent to angle 4. They are alternate interior angles. So alternate interior angles are congruent. So if we have alternate interior angles, then we also are going to have alternate exterior angles. So alternate exterior angles are angles that are outside the parallel lines and on opposite sides of the transversal. Okay, so in this picture here, my set of alternate exterior angles would be angles 1 and angle 8. Angle 1 and angle 8 are alternate exterior angles. They are outside and opposite sides. And again, notice how they're congruent to each other. So angle 1 is congruent to angle 8, alternate exterior angles. So then another set of alternate exterior angles in this picture would be angle 2 and angle 7. Angle 2 is congruent to angle 7. So the takeaway from alternate exterior angles is that those angles are also congruent. Okay, and then the last relationship that's created from parallel lines is known as consecutive interior angles. Consecutive interior angles are angles that lie on the same side of the transversal and inside, so same side, inside. So in this picture here, my set of consecutive interior angles would be angle 3 and angle 5. So angle 3 and angle 5, they are not congruent to each other, but they are special because they're going to be supplementary angles. Angle 3 and angle 5 are going to add to 180 degrees. Now, there's a whole proof behind this as to why they're going to be supplementary. It goes back to vertical and corresponding. You see how angle 5 is corresponding to this angle 1 right here? So 5 and 1 are congruent, and then 1 and 3 are supplementary because they're a linear pair. And so if 5 and 1 are congruent, then that means that this also could be called angle 5 if you wanted it to be, because they're the same angle, they're corresponding, they're congruent. And so since 5 and 3 now are a linear pair, then they're supplementary. So just a walkthrough as to why angle 3 and angle 5 are supplementary. Also in the same picture, we have another set of consecutive interior, and that would be angles 4 and angle 6. Again, same side, inside, and so their measure is also going to be 180 degrees. All right, so this is all of our angle relationships. We're going to be using these relationships to learn about triangle proofs.